NENOMATICA, where mathematics meets YouTube excellence. Exponential equations. Today we'll solve an exponential equation step by step, following a clear method to find the value of x. Let's begin with our problem. We need to solve the exponential equation. 0.2 raised to the power of 1 minus x equals 125. Let's start by rewriting 0.2 as a fraction. 0.2 can be written as 2/10. Now, let's simplify this fraction. 2/10 simplifies to 1/5. Next, we'll write 1/5 using negative exponents. 1/5 can be expressed as 5 to the power of -1. Now, we can apply the power rule for exponents. The rule states that when we have a power raised to another power, we multiply the exponents. So, 5 to the power of -1 raised to the power of 1 minus x becomes 5 to the power of -1 times 1 minus x, which simplifies to 5 to the power of x minus 1. Let's rewrite 125 as a power of 5. Since 125 equals 5 cubed, we can rewrite our equation as 5 to the power of x minus 1 equals 5 cubed. When we have the same base on both sides of an equation, the exponents must be equal. This gives us x minus 1 equals 3. Finally, let's solve for x. Adding 1 to both sides, we get x equals 4. Let's verify our answer by substituting x equals 4 back into the original equation. We get 0.2 to the power of 1 minus 4, which is 0.2 to the power of -3. This equals 5 to the power of -1 to the power of -3, which is 5 to the power of 3. That's 125, confirming our answer. Today, we're going to work through a challenging problem involving exponential expressions with different bases. Let's start with our problem. We need to solve for x in the following equation. We have the fraction 3 raised to the power 3x times 3 raised to the power 2x minus 4, all divided by the product of 3 raised to the power x minus 1 times 2 raised to the power x times 3 raised to the power x. This equals 2 raised to the power -x. Our first step is to simplify the left side of the equation by combining like terms in the numerator and denominator. Let's start with the numerator. We have 3 raised to the power 3x times 3 raised to the power 2x minus 4. Using the product rule of exponents, when we multiply expressions with the same base, we add the exponents. So this becomes 3 raised to the power 3x plus 2x minus 4, which is 3 raised to the power 5x minus 4. Now, let's simplify the denominator. We have 3 raised to the power x minus 1 times 2 raised to the power x times 3 raised to the power x. First, we can combine the terms with base 3. Using the product rule of exponents again, 3 raised to the power x minus 1 times 3 raised to the power x becomes 3 raised to the power x minus 1 plus x, which is 3 raised to the power 2x minus 1. So our equation becomes 3 raised to the power 5x minus 4, divided by 3 raised to the power 2x minus 1 times 2 raised to the power x equals 2 raised to the power -x. Now, we can use the division rule of exponents. When dividing expressions with the same base, we subtract the exponents. So, 3 raised to the power 5x minus 4 divided by 3 raised to the power 2x minus 1 becomes 3 raised to the power 5x minus 4 minus 2x plus 1, which simplifies to 3 raised to the power 3x minus 3. But I noticed that in the solution provided in the image, they multiplied both sides by the denominator to eliminate the fraction. Let's follow that approach to match the solution process exactly. On the right side, we can simplify by combining the terms with base 2. 2 raised to the power x times 2 raised to the power -x becomes 2 raised to the power x plus -x, which is 2 raised to the power 0. And 2 raised to the power 0 equals 1. Since 2 raised to the power 0 equals 1, we can remove this term from our equation. So our equation becomes 3 raised to the power 5x minus 4 equals 3 raised to the power 2x minus 1. Now, we can use a key property of exponential equations. If the bases are the same, then the exponents must be equal. Since we have 3 raised to the power 5x minus 4 equals 3 raised to the power 2x minus 1, we can set the exponents equal to each other. So, 5x minus 4 equals 2x minus 1. Now, we'll solve for x using algebra. Let's subtract 2x from both sides. This gives us 5x minus 2x minus 4 equals -1, which simplifies to 3x minus 4 equals -1. Simplifying the right side, we get 3x minus 4 equals 3, and adding 4 to both sides gives us 3x equals 3. Finally, dividing both sides by 3, we get x equals 3 divided by 3, which is 1. Therefore, x equals 1 is our solution. Let's verify our solution. Welcome to our lesson on solving exponential equations. Today, we'll work through an example of how to solve a complex exponential equation step by step, applying key principles of exponent manipulation and algebraic simplification. Let's solve the following exponential equation. 25 to the power of x plus 5 to the power of 2x minus 1 divided by 9 to the power of x minus 1 plus 3 to the power of 2x minus 1 equals 15 over 2. Our first step is to rewrite the expression using basic exponent properties. We know that 25 equals 5 squared, so 25 to the x equals 5 to the power of 2x. And for the second term in the numerator, we'll rewrite 5 to the power of 2x minus 1 as 5 to the 2x times 5 to the negative 1. In the denominator, we know that 9 equals 3 squared, so 9 to the power of x minus 1 equals 3 to the power of 2x minus 2, and we'll keep the second term as is for now. Now, let's continue rewriting our expression. In the denominator's second term, 3 to the power of 2x minus 1 can be rewritten as 3 to the power 2x times 3 to the power of negative 1. Let's factor out the common terms in both numerator and denominator. In the numerator, we can factor out 5 to the power of 2x, leaving us with 1 plus 1/5. Similarly, in the denominator, we'll factor out 3 to the power of 2x. When we do this, the first term becomes 3 to the power of 2x minus 2 divided by 3 to the power of 2x, which simplifies to 1 over 9. And the second term becomes 3 to the power of negative 1, which is 1/3. Let's reorganize our equation to separate the exponential parts from the constant parts. We can rewrite this as the ratio of 5 to the power of 2x over 3 to the power of 2x multiplied by the ratio of 1 plus 1/5 over the sum of 1/9 plus 1/3. Let's simplify the second fraction. 1 plus 1/5 equals 6/5, and in the denominator, we need to find a common denominator for 1/9 and 1/3. 1/9 is equivalent to 1/9, and 1/3 is equivalent to 3/9. So the denominator becomes 1/9 plus 3/9, which is 4/9. To simplify the constant fraction, we'll multiply 6/5 by 9/4. That's equivalent to multiplying 6 by 9 in the numerator and multiplying 5 by 4 in the denominator. Now let's calculate. 6 times 9 equals 54, and 5 times 4 equals 20. But actually, simplifying further, 54 over 20 can be written as 27 over 10 by dividing both numbers by 2. Let's clean up our exponential part. We can rewrite 5 to the power of 2x over 3 to the power of 2x as the quantity 5 squared over 3 squared, all raised to the power of x. 5 squared equals 25, and 3 squared equals 9. So we now have 25 over 9, all raised to the power of x. Let's calculate the right side. 15 times 10 equals 150, and 2 times 27 equals 54. So we have 150 over 54. Dividing both numbers by 6, we get 25 over 9. Now we have 25 over 9, all raised to the power of x, equals 25 over 9. This means that 25 over 9 raised to the power of x must equal 25 over 9 raised to the power of 1, which means that x must equal 1. When solving exponential equations, remember this important rule. Let's look at our example. We need to solve the exponential equation 4 raised to the power of 5x plus 1 equals 2 raised to the power of 762. The first step is to rewrite our equation using the same base. Notice that 4 equals 2 squared, so we can rewrite 4 as 2 raised to the power of 2. Now we can use the power rule, which states that a to the power b, all raised to the power c equals a to the power of b times c. So 2 squared raised to the power 5x plus 1 equals 2 raised to the power of the product. 2 times quantity 5x plus 1, which is 10x plus 2. When we have the same base on both sides of an equation, we can set the exponents equal to each other. This gives us 10x plus 2 equals 762. Now, we'll solve for x. First, we'll subtract 2 from both sides of the equation. This gives us 10x equals 762 minus 2, which is 760. Finally, we'll divide both sides by 10 to isolate x. This gives us x equals 760 divided by 10, which is 76. Let's verify our answer. If we substitute x equals 76 back into the original equation, 4 to the power of 5 times 76 plus 1 should equal 2 to the power of 762. We'll leave this verification as an exercise for you. So, the solution to our equation is x equals 76. Remember the key steps. First, convert to a common base. Second, apply the power rule. Third, set the exponents equal. Finally, solve the resulting linear equation. Let's look at our equation. 3 raised to the power of 3x minus 1 plus 1 equals 10. Our first step is to isolate the exponential term by subtracting 1 from both sides. This gives us 3 raised to the power of 3x minus 1 equals 10 minus 1, or 9. Next, we recognize that 9 equals 3 squared. So, we can express our equation as 3 raised to the power of 3x minus 1 equals 3 squared. Since the bases are the same, we can equate the exponents. This gives us 3x minus 1 equals 2. Let's add 1 to both sides to isolate 3 raised to the power of x. This gives us 3 raised to the power of x equals 3. We can rewrite this as 3 raised to the power of x equals 3 raised to the power of 1. Since the bases are equal, the exponents must also be equal. Therefore, x equals 1, which is our final answer. Let's verify our solution by substituting x equals 1 back into the original equation. When we substitute, we get 3 raised to the power of 3 times 1 minus 1 plus 1. This simplifies to 3 raised to the power of 2 plus 1, which equals 9 plus 1, which equals 10. Since this matches our original right-hand side of 10, we've confirmed that x equals 1 is indeed the correct solution. Here's our exponential equation. We have 9 raised to the power of 3x equals 3 times 3 raised to the power of x plus 4 times 3 raised to the power of x minus 1. First, let's rewrite 9 as 3 squared. This will allow us to express everything in terms of the same base of 3. Next, we apply the power rule, which states that a raised to the power b, all raised to the power c, equals a raised to the power of b times c. So 3 squared raised to the power of 3x becomes 3 raised to the power of 6x. Now, let's simplify the exponent on the right side. We have 1 plus x plus 4 plus x minus 1. This simplifies to 2x plus 4. When we have the same base on both sides of an equation, the exponents must be equal. So we can say 6x equals 2x plus 4. To isolate x, let's subtract 2x from both sides of the equation. This gives us 6x minus 2x equals 4. Simplifying the left side, we get 4x equals 4. Finally, we divide both sides by 4 to solve for x. Therefore, x equals 1. Let's look at our example problem. 3 to the power of x plus 1 plus 3 to the power of x minus 1 equals 30. First, let's rewrite these exponents. For the first term, 3 to the power of x plus 1, we can rewrite it as 3 to the power of x times 3 to the power of 1, which is simply 3 to the x times 3. For the second term, we have 3 to the x times 3 to the negative 1. 3 to the negative 1 equals 1/3. So this term becomes 3 to the x times 1/3. Let's factor out 3 to the x. We get 3 to the x times the expression in parentheses. 3 plus 1/3. Now, let's simplify what's inside the parentheses. We need to add 3 and 1/3. Let's convert these to a common denominator. 3 equals 9/3. So we add 9/3 plus 1/3, which gives us 10/3. Next, we need to isolate 3 to the x. We divide both sides by 10/3. Let's calculate 3 times 30 divided by 10. 3 times 30 is 90, and 90 divided by 10 is 9. Since 9 equals 3 squared, we can write 3 to the x equals 3 squared. Since the bases are the same on both sides, the exponents must be equal. Therefore, x equals 2. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.